आपका नहीं है, कोई भी नहीं है। ठीक है, एसएससी ये आपने पूरा बनाया है। मैसेज को क्या? हाँ, चलता था, ठीक है, चलता है। सी है क्या? आज जी टाइप चलता क्या? चले चलेगा। वाइट ना लगाओ, कोई दिक्कत नहीं, वाइट ना रहना। नहीं नहीं सर, भरोसा करो। ये कब तो उसको क्लास नहीं है। नहीं है तो क्या ना हो, नाइन का पता, वेंसडे से तो जुड़ा गया है। सैटरडे छुट्टी कंसीडर की है। अब से वेंसडे बेटा ना, मुझे अब से वेंसडे को बेटा, वेंसडे को लेता जो ईवी को पढ़ा रहे हैं।
Good afternoon, all my dear students. So, am I audible? And is it my screen is visible to you?
Yes, sir.
Okay, okay, thank you. So, dear all students, as per our syllabus, so this is our syllabus. Okay, no, this one. Okay, SY Tech. Yes, fine. So, this is our syllabus. In the previous lecture, we have to completed the unit number 6, that is programmable peripheral interface. There is a very small chapter. Within 4 hours, I have to complete it. And today we have to start with new unit, that is unit number 7, programmable communication interface and 8087 NDP. The NDP is nothing but it is a numeric data processor. NDP is nothing but it is a numeric data processor. So how we are going to interface, how we are going to interface 8087 with 8086. That's one we have to study. Up to now, what we studied, just 5 minutes, I have to refresh you from the beginning. In the first unit, we have studied 8085 microprocessor architecture features and pin diagram of 8085 we studied. In the second unit, we studied same thing with 8086 we studied, that is 8086 architecture, internal operation, machine language, all the addressing modes and instruction execution timing we studied in the 8086, that is second unit. First unit 8085 and second unit is related with 8086. And in the third unit, especially we have to study all the instructions, whatever comes under the microprocessor 8086. We have to study all the instructions, near about 70 to 80 instructions we have studied, right? And in the unit number 4, we studied regarding bus architecture, that is system bus, data bus, and control bus. Along with that, the minimum mode configuration and maximum mode configurations we studied. So that is in the unit number 4. And in the unit number 5, we studied interrupts. In that, maskable interrupts, non-maskable interrupts, hardware interrupts, software interrupts, and interrupt service routine. Along with that, we studied 8 to 59 block diagram and architecture, and also functional operations we studied. Along with that, 8 to 57 also we studied. Same way with this uh, block diagram, functionality, internal operations, 8 to 57 and 8 to 59 we studied. That's in the solving the problems of interrupts, right? So again, in the last, recently we studied programmable peripheral interface. This one is whatever the problems is not solved by the interrupts with 8 to 59 and 8 to 57, those problems we have to solve by using 8 to 55. This is the connection between one unit to another from beginning to this up to whatever we have to cover, isn't it? So today, once we studied all this concept in the microprocessor from beginning, architecture, introduction, pin configuration, features, to till unit number 6, that is to solve all the interrupt problems by using 8259 programmable peripheral interface with the mode of operations, with the block diagram, architectures we have to study. So next, after we studying all this, actually this is enough. But some of the extra core processors we have to interface with the 8086 core processor like 8087. 8087 is nothing but what? It is the extended version of 8086, and 8086 we have to call it as a main processor, and 8087 we call it as coprocessor. So what coprocessor will do? The coprocessor is cooperating with the main processor, and some of the extra features we have to implement it in the 8087, and that is supporting with 8086 processor. So by using this coprocessor to the main processor, our arithmetic, it means that the numeric data processor is going to be faster in the execution. There is a fast execution purpose. We have to use one of the coprocessor, nothing but 8087 along with 8086. So that one we have to study in this unit. In this unit of 7, what is our main aim of to purpose study? The coprocessor like 8087, which is going to be supporting with 8086 by interfacing both together. By interfacing both together, and 8086 is act as like a master, and 8087 is act like as a slave. So all of you know the master and slave concept. That is very fantastic explanation is happened in the unit number 7. So now I have to start with this unit number 7, that is programmable communication interface with 8087. So before that, I have to transfer these nodes. This is the unit number 7, 8087 numeric data processor. So this one, before that started, all of you come to your WhatsApp group. So in that WhatsApp group, come to microprocessor DSY. So this is the microprocessor DSY. Here I have to dump to this unit number 7 nodes. Just a second. Okay. Yes, fine. So this is microprocessor unit number 7. Yes, please all of you find this PDF. Microprocessor nodes unit 7. Okay. So download this from this book. It's fine. So open these notes. Here, otherwise you have to observe my screen. So okay. So this is the well-defined notes for your reference purpose. In this unit, we are using 8087 numeric data processor. Actually, it is a coprocessor. This coprocessor we have to use it with 8086. So here, first we will come to know the features. That is, 8086 numeric data processor is specially designed to perform arithmetic operations. What are the arithmetic operations? That is addition, subtraction, multiplication, and division, and modulo also. To solve all these arithmetic operations very fast compared to the main processor, that's what we are using 8087 core processor. Okay. So in that 8087 can operate on the data of integer, decimal, and real types of numbers. That is ranging from 2 to 10 bytes. 1 byte is equal to 8 bit. 10 bytes in the sense 80 bits. The range is used in the numeric data processor. So the instruction set includes in the square root or in the exponential and in the longest, in the trigonometric functions, additions, various forms of multiplication, subtraction, division, addition. All these operations are very easily and with a fast speed. We have to solve this by using the coprocessor of 8087. For example, in the 8087, can multiply 264-bit real numbers and 27 microseconds of calculated square root in the 36 microseconds. And in this 8086, it requires 2 milliseconds and 20 milliseconds. But in this 8087, they will use microseconds, not a milliseconds. Half of the execution timing is going to be reduced. That's what we have to use 8086 coprocessor. So in the numeric data processor, it acts as a host and coprocessor. So as I said, 8087 is a coprocessor. It is not a processor. But this coprocessor is interfacing with the main processor of 8086 configuration and must be operate with either the 8086 or 8088 because the 8087 is used for only numeric data processing and cannot fetch its own instruction. So it is the in between 8086 and 8088. That's what we have to use this one as a coprocessor. Okay. So now we will see that the pin diagram of 8086 pin configuration. So this is the pin configuration of 8087. All pins. So the pin number 1 we are used for ground, and pin number 40 we have to use it for power supply. That is nothing but VCC. And remaining address lines from AD0 to AD14, and here it is AD15 is there. So pin number 16, 1 to pin number 16 and pin number 39, we have to use all the 16 address lines AD0 to AD15. It means that the address lines of 16 in number. And non change we have to use it for pin number 17 and 18. And at the clock signal clock generator we compulsorily used. So in the 8086 we are not using any signal clock generator, but in the 8087 compulsory we have to use the signal clock generator because it is a coprocessor. Whatever the main processors are there, we don't use directly the signal generator, but whenever we are using a coprocessor, that time we are compulsory to use clock generator. So in the 8087 coprocessor, we are using a clock generator at the pin number 19, and this pin number 20 is the ground. So here the set and reset pins we used at the pin number 21 and ready state used at pin number 22. So busy signals at pin number 23 and that signal lines, that is 0, S0 and S1 with the pin number 24 and 25 respectively. And at the pin number 26 we use the S0 and S1, S2, three signals we have to use. And again here the non change we used at 18 and 17. Along with that 29 and 30 also we are using the same. So the pin number 31 we use it for request and go to, and pin number 32 for interrupt, pin number 33 use it for again request, pin number 34 bus high enable purpose we are using, with 35 used for again that is address lines of 16, 17, 18 and 19, totally 20 address lines. Because of 4 are acknowledging here with the instruction pointer, all those pins we have to use it. Okay, so here in the pin diagram of 8087 the address or the data buses status ready, reset, clock, ground and power pins having the same position of the 8086. As you saw in the compare with 8086 and 8087, you will get effective of this. And the busy pin to the host swap test pin, and the request go to pin to the host swap request GTO, GT0 and GT1 pins. So the interrupt pin to the interrupt management logic purpose used, and request pin to the bus in request and grant pin of the independent processor. So enter this pin configuration with a particular or individual pins indicated by this. Okay. So now we will see that explanation of each pins. Out of 40 pins, explanation of all the pins, we have to go through it in the 8086. Please all of you remember the 8086 is the main processor and 8087 is the core processor. So in the 8087, whatever they are using AD0 to AD15 address lines, that is, these are the multiplexed address or data lines which carry the address during the first clock cycle and the second clock cycle onwards. Okay, first clock cycle it is compulsory to carry, and from the data from second clockwise also it is further carried all the data. That is AD0 to AD15, address line 0 to address line 15, and next one address line 16 to address line 19. These are the multiplexed address status lines, and these addresses are carried during the first clock cycle. Similarly, the S1 and S6, S4 and S3 status lines are permanently high. We have to say permanently high, while SY is always low. In that pin configuration, you have to check it. So next one, bus high enable pin at the S7. During this first cycle, the bus high enable, which is used to enable the data onto the higher bytes of 8086. So the data bus offer that works as status lines of S7 also, and there are two uh, signals are there, QS1 and QS0. These are the Q status. Q in the sense what? It is a Q, S1 and S0. Means status of 0 and status of 1 of the Q input signals, which provides the status of each instructions present in a queue. So for example, if QS0 and QS1 you take in the truth table with a 0, 0, 0, 1, 1, 0 and 1, 1 combination. So the status of this, if both the 0, QS0 and QS1, both are 0, then no operations. And S1 and S0 are in 0, 1 combination. There is a coprocessor of 8087 removes first byte from the queue, and the 1-0 combination, it clears all the queue. Whatever the data is present in the queue, totally it will clears. So if the Q status of 0 and Q status of 1 both are high, then 8087 removes operand from the queue, that is subsequent bytes. So this combination is working functionality of two Q status, 0 and 1 states. Okay. So next one, the pin is the interrupt pin. As already you know that the interrupt is nothing but it is a sub abnormal execution in the programming. That one is covered by the interrupts. So it is an interrupt signal which changes to the high when the unmasked exception has been received during the execution. Okay. So next one is the busy pin in the 8087. It is an output signals. Whenever it is high, it indicates that the busy state. In this, if it is high means the meaning is it, this one is the busy state to the CPU, and it is reset means tested. Okay, so once it is high, you have to test it again. Busy is becomes to the normal state, and data is continuously start to transfer. So next pin is ready. So this ready pin, it is an input signal used to inform coprocessor whether the bus is ready or not. Otherwise, it is to receive the data from the processor. Okay. So just it is going to be check the condition of either data transmission is going to be ready or not. High and low. Low means not ready. High means ready. So next one is the reset pin. It is an input signal used to reject the internal activities of the coprocessor and prepare it for further execution. Set and reset. If the data is continuously flowing in a normal manner, then there should be a set it. Otherwise, you reset and to transfer the data. So next one, clock. As I said, due to the 8087 is a co-processor, we have to compulsory to use the clock generator. That is, clock generator input provides the basic timings for the processor to operate it. So next one is the last pin, that is 40th pin is the VCC purpose we have to connect it. VCC is nothing but power supply to the coprocessor. It is a power supply signal connected with 5 volt. Just for 5 volt is more than enough for the 8087. So next one is the request and grant signals. RQ means it is a request and GT means it is a grant signals. So two grant signals are there, GT0 and GT1, grant 1 and grant 0. So in these signals, the 8087 coprocessor, that is to gain the control of bus from the host, as well as the 8086 and 8088. Why we are using 8086 and 8088? Because these two are the main processor and 8087 is the co-processor to supply the data, and the execution speed is to fasten it. For that purpose, we have to use it in the 8087 as a co-processor along with 8086. Okay. So next one, three signal lines, that is S0, S1 and S2. These are the status signals that provides the status of the operation which is used by bus controller and 8088 to generate control signals. Actually, the up to the 8086, next version is 8088. That is the main processor. But between 8086 and 8087, sorry, 8088, we have to use the 8087. That is the core processor. Okay. So this one table I given you for the better understanding whenever that is used and whenever that is not used. With the S0, S1 and S2 signals in the three rows, that is, see, here S1 and S2 I make it as a down care. X in the sense what? It is a down care for unused. And first these two conditions are for unused, and next remaining the two conditions for memory read and memory write. The last one is for passive, because all are high in the signals, it automatically becomes a passive one. So this is all about the pin configurations of 8087 coprocessor numeric data processor NDP. Okay, so by using this, once you come to know this pin configuration of 8087, next we will go for how we the NDP data types we are using. So in the numeric data type processor, there are 7 types of different data types are there. Those are nothing but word integer and short integer, long integer. One main category is integer. Under the integer, there are 3 types: word integer, short integer, and long integer. And one more is used for packed BCD. BCD means binary code digit. Okay, so that is the fourth one in the second category. And in the third category, we use it for real. Again, in the real, there are 3 types: short real, long real, and at last one, temporary real. So one by one, all these 7 data types, these 7 data types are only specific for the core processor of 8087. So in this 8087, always it works with the 80 bits. Why it is 80 bits? Because 2 bytes to 10 bytes. So 1 byte is equal to 8 bit, as you know. So 10 bytes in the sense 80 bits. 10 into 8 is 80 bits data capacity is having in 8087. That's what the execution process is too fast compared to other processor. So in this, the data internally, which is considered as temporary and real format. So the totally 8087 is the number of memory and internally number of converted 80-bit temporary memories, and it is real format before the formatting of the computation. Okay. So now in this data types, first one we take it as an integer. So in the integer, there are three types: word integer, short integer, and long integer. So first one, I have to take it as a word integer. The word integer format is, we have to use it 0 to 15, means 16-bit length. That is the 15th length is the sign bit, and remaining all bits we have to use it for magnitude. So sign bit, if it is 0, then it is a positive number. In the sign bit, if it is 1, then that is for negative number. Please you keep him remember in your mind, whenever the sign bit is 0, normally we say that is a positive number. If the sign bit is having a 1, then it is a negative bit. Okay. So that is the range of minus 327682 plus 32768, because it's a 2 bytes. So next one in the integer, that is a short integer. In that short integer, it is 32 bit. Word integer is 16 bit length. Short integer is 32 bit length, and that format is 0 to 31. It becomes a 32 bit. So the 31 bit we use for sign bit, and remaining all are magnitude. Okay, so here we have to use 4 bytes, and entire the short integer is double of word integer. Just to remember, and multiply with the word integer, automatically you have to form the short integer. So next one is long integer. Again, it is double of short integer. So short integer is a 32-bit capacity, but the long integer is 64-bit capacity. And this format is 0 to 63, means 64, and all up 0 to 62 is the magnitude bits, and last one is a sign bit, that is for 9 into 10 raised to 18 to 9 into 10 raised to 18. So very huge number, up to 80 bits you have to get this length. That's the range of long integer. Okay, so this is regarding of integer. So in the integer, three types, just remember: word integer, short integer, and long integer, with a 16-bit capacity, 32-bit capacity, and 64-bit capacity respectively. So in the next second category, that is packed BCD, the total size of the number is 10 bytes and 80 bits. 10 bytes is nothing but it is the 80 bits in the packed BCD. Here the number is represented as series of 18, because 9 into 10 raised to 18 to 9 into 10 raised to 18, what we are using, plus to minus, that's what we have to consider, that's 18 series packed BCD digits. So hence the each byte has two BCD digits, and positive number, negative number is stored, but negative number is not stored in the 2's complement. Only positive numbers are stored in the 18 series. So the most significant bit of 10th byte, means 18th bit, it carries the sign bit, and remaining 7 bits are don't care. So that don't care we have to represented by the X symbol here. 0 to 79, totally 80 bits capacity in the packed BCD, and 10 bytes means 80 bits. Range is minus 10 raised to 18 plus 1 to plus 10 raised to 18 minus 1. This is the range uh, it is occupying, that is packed BCD. Okay. So next in the third category of the data type, that is real. So in this again there are three types: short real, long real, and uh, temporary real. Okay. So in the short real, it is also called as single precision format sometimes, and it is a 32 bits are used to store the number. So the 23 bits are used for Mantissa purpose, and 8 bits are used for biased exponent, and last one bit is used for sign purpose. If it is 0, then the entire number is positive. If it is 1, then the entire number we represent as negative. So last bit we have to represent it by a sign bit. And this is the format. So here 0 to 22 bits we use it as a mantissa, and 22 to 30 we use it as an exponent. Here I am mentioning E, it means that exponent, and the last bit 31 to means 31th bit is a sign bit, either 0 or 1. 0 for positive number and 1 for negative numbers. So that is the range of plus or minus 1 into 10 raised to minus 32. Approximate number I have to mention here, but this is a fixed number for the short real. Okay. So next one is the long real. It is double of short real again. So this is, if it is a 32 bit capacity, then automatically it become a 64 because double of short. So here it is double precision format, and the 64 bits are used for to store number. So 52 bits are used for the mantissa, and 11 bits are used for biased exponent. One bit is again used for sign purpose, that is sign of the number. So this is the format of 0 to 64. 3 means total 64 bit capacities, and the range is plus or minus 10 raised to minus 308 to plus or minus 10 raised to 308. This is the one range you approximate. I have to mention here, not exactly. So approximate, you have to remember this number. So in the last real, there is a last data type, that is temporary real format. So in this temporary real format, it is also called extended precision format. So in this extended precision format, the 80 bits are used to store the number, that is 10 bytes. Is nothing but 80 bits are used to store the number, and 64 bits are used for mantissa, 15 bits are used for exponent, and last one bit is used for sign of the number. Okay, so this one we have to use it. So next one is the bias value of this is 163 at approximate number in the base 10. I have to format it. So that format is 0 to 79. It means 80 bits. So 0 to 63 is mantissa, and 64 to 78 is exponential, and the last bit 79th bit is sign purpose. Okay, and the range is plus or minus 10 raised to minus 49322 plus or minus 10 raised to 4932. So this is the things we have to use the data types in the 8087 coprocessor. So in this, just you remember integers. In the integers, there are three types: word integer, short integer, long integer, and okay. So these are the data types. Mainly 7 data types we have to use. Three numbers, three different integers, that is word integer, short integer, long integer, and packed BCD number, and three more in that real. that is short real, long real, and temporary. So all dictate to dictate, I have to explain it here. Just you go through these notes, okay? And whatever I explained now, very easiest manner I have to prepare for your understanding. Please, you have to refer it. So once you come to know the after knowing this pin configuration, features and data types of coprocessor 8087, that is numeric data processor. Next, we will go for how to do the interfacing with this 8087 coprocessor along with 8086 main processor. Okay, so as of early, we have insisted that the 8087 is a coprocessor and it is a very short one. Just this one we are interfacing with the 8086 because 8086 is the main processor. So how we will do this interfacing? Okay, because that co-processor, they will not work without main processor. Always they have to take the support from main processor and they have to fasten the execution timing. So this way we are using 8087 core processor with 8086 main processor. So as a core processor of 8087 which is connected with 8086, then the 8086 operates in the maximum mode. Why it is maximum mode? Because in the unit number 4 you have to study it, that is minimum mode configuration and maximum mode configuration. Here I am using 8086 is a maximum mode configuration because the 8087 is a core processor and whatever arithmetic execution process is there, that is used with 8086. That's why we have to say this 8086 and 8087 interfacing is a maximum mode configuration. Okay, so in this the 8 to in the maximum mode configuration, just all of you recall, four main processors we have to use it along with 8086. That is 8282 we use it, 82 86 we use it, 82 88 we use it, and 82 84 we use it in the maximum mode configuration of system bus. Just to go and check it, the four extra core processor we use it along with 8086. So what are the extra core processor? 8284 for the clock generator purpose we are using. 8282 for the latch purpose we are using. It is provides the latches. And 8286 we use it for data transmitter as well as data receiver purpose we are using. And 8288 it generates the control signals like S0, S1 and S2. Three control signals it generates for the input and to correct activating the processor. And one more, we are using 8259 programmable interface controller is used to accept the interrupt in the interrupt chapter of fifth, and 8087 and sent it to the microprocessor. Very easiest one, whatever. Just to remember in the unit number 4, all those we have to use it very well. Okay. And in the next features of interfacing, the 8086 is called as a host and 8087 called as a coprocessor, as I already said, because the master and slave concept. And only the 8086 can fetch the instructions because it is a main processor. But these instructions also enter into the 8087 because 8087 is a coprocessor and it is accepts all the instructions whatever sent by the 8086 main processor. So the 8087 treats 8086 instructions as numeric data processor. Okay, and here some escape is used for the prefix of 8087 instructions. When an instruction is prefixed with MSB, means most significant bits, and it is countered with coprocessor of 8087 is activated. So if the escape is present, that is 8087 executes the instruction and 8086 discard it. If the escape and insertion is not present in the 8086, because the execution of 8087 is faster than the 8086, so that is we are using the interface of 8087 along with 8086. This one point you have to remember. So in next one, uh, the 80867 is begins with the execution, and whenever it is busy in the output high, which is connected to the test of microprocessor, there is a one test pin we are using in the pin configuration of 8087. Just you have to recall that. And the 8087 execution timing is automatically become increases. So during the execution of 8087, it needs read and write from the memory. Then it does not, so sticking with the cycle from the microprocessor in the following manner, that is request and grant signals of 8087 is connected, and request of grant signals of microprocessor. So the 8087 is the most popular and it is more active over than the request pulses. So the 8086 completes the current bus cycles and it gives the grant pulses, enter the hold states. So the 8087 uses the stored system bus to perform the data transfer with the memory. And this 8087 gives release to the pulses and returns the system back to the microprocessor. So these all other characteristics or we say features are very important. And some more is there, that is the 8086, the main processor, which can request the result of 8087 operation for the execution and wait instructions. During this execution of an exception occurs, which is unmasked. Unmasked means what? Non-clear of the 8087 interrupts. Using this, the microprocessor of interrupt output pin through the configuration that is going to be handled by 8259 coprocessor, as we studied in the fifth unit of this microprocessor. So these all 10 points are very, very essential, very, very important features of 8087, which is interfacing with 8086. Here also, I will give you the block diagram clearly as in the maximum mode configuration. So here just I am missing, this is what 8284 clock pulses, clock generator. As you go and turn previous pages of unit number 4, you will get it clearly. So 8284, this is for the clock pulses generating we are using, and 8282, this is for 8-bit latch. 8286, this is for data transmitter as well as data receiver. And 8288, this one is used for bus controller. So this is the main processor what we use, that is 8086, and here we are using co-processor like 8087. So this is the block diagram of interfacing between 8086 and 8087. This is the interfacing concept. Okay. So this diagram and this block diagram you have to follow between whatever I explained in this all 10 points. So in all 10 points, every point is very important for your examination point of view, for the explanation point of view. And this diagram, just you have to go through it. This diagram is totally same as your maximum mode configuration, except only we are using one of the co-processor, that is 8087 co-processor. Here this one we are using. Okay, so just you go through this block diagram, that is entire explanations you have to get. So now what we will do, there is a q selective lines, qs0 and qs1 lines are used by 8087 to monitor the queue of 8086 main processor. Okay, So the 8087 needs to know whenever the 8086 will decode the escape instruction. So it is synchronizes the queue with 8086 using QS0 and QS1 as follows. This is the one truth table. How we use the Q signal S0 and Q signal S1 with 0, 0, 0, 1, 1, 0 and 1, 1 combination. If both are 0, then no operation will be happened. If anyone is high and anyone is low, that time if 0, 1 condition, 8087 removes the upward from the queue, and 1, 0 condition, it clears entire queue. If both the input is high, then 8087 removes the operands. So next one, there is a one processor architectures I have to made it here. So this is not your exam point of view. Okay. So here in the monitor control logic maintains the 6-byte instructions queue, and it tracks the instruction execution, that sequence of the host, and the instruction currently being executed by the host is an escape instructions. So the 8087 decodes the external upward to perform the specific operations also. And it also captures the operand and operand addresses instruction other than the escape instructions. So simply it is ignored by the 8087 because that is used as a co-processor with the 8086 main processor, right? So this is the all some extra explanations I have given you in the notes, and that bit-to-bit execution also I have given you. So next I will go to directly for the underflow and overflow. That precision error. Here means precision error and underflow level. So if a mask the error when it will not be cause an interrupt, but instead of 8087 will perform the standard response and it proceeds when the next instruction in the sequences. So the interrupt request depends on the interrupt enable mask, that is IEM, interrupt enable mask in the control register, and all the interrupts are disabled except when the CPU execution waiting instructions, that is interrupt enable mask is equal to 0. And in this, the error handling interrupt routine, which is the instruction pointer, and to operand the pointer which is stored in the 8087. So the examiner of the 8087 by first putting them into the memory. And the last one, that is the remaining bits in the control register that provides the flexibility in the controlling precision, that is PC, and rounding precision, that is RC, and infinity precision, that is IC. So these bits are defined with 00 means they are 24-bit precision, 01 for received, and 10 means 53-bit precision, and 11 means 64-bit precision. So in that RC, that RC means rounding bits with the 00 means round to request, 01 means round to towards infinity, and 10 means round towards positive infinity. And if both are 1 means that is the truncation. So in the IC means that is infinity bits. The infinity bit is 0 indicates that it is positive infinity to negative infinity are treated as the single infinite numbers. And in the 8087 interfacing, whenever the infinity bit is 1, it indicates that positive infinity to negative infinity are treated as two-signed infinities. Okay, so this is the things of 8087. And at one line, at the last, during the reset of initialization of the 8087, it sets the program counter to all, and that rounding bits, infinity bits, and interrupt enable mask is returned to 0, and all the error mask bits to 1. So the tag register holds the status of the contents of the data register, and each data register is associated with two tag bits, which is indicate whether the contents of the value 0 or 01 is special value of uh, numeric arithmetic non-infinity or denormal. 10 means 10 bits means 80 bits are empty. Okay, so this is the things only as per syllabus in the unit number 7, just to study the features of 8087 NDP, that is numeric data processor, and architecture. I have to explain that architecture with the block diagram. You have to explain only two topics. Actually 4 hours is not need for this one, but only two topics, 1 hour for uh, numeric data processor and 1 hour for block diagrams. That one you have to study. Okay, so this is for your unit number 7. So dear all students, what you will do now, take a 20 minutes time, and whatever I covered till now, just you go through it. Now it is 3:40, up to 4 o'clock. You have to go through these notes, whatever I shared with you today, that unit number 7 notes. Just you go through it, and if anything you are not understood by these notes, please you come and discuss with at exact 4 o'clock. Okay, so please all of you take this 20 minutes as a study hour and start your study now. Okay, dear all students, is there any doubts or difficulties during this unit number 7 study hour? Please, any doubts are there? Now it's open forum to ask everyone. If you have any doubts, free to discuss. I'm waiting your questions, please. A very easy topic, this one. Very, very easy. Just for 8086 block diagram and architecture, you have to study. And features of 8087, you have to study. And data types. There are 7 data types: short integer, long integer, BCD, uh, multiplex BCD, and short real, long real, and temporary real. All those just you have to go through it. Okay. So, is there anything apart from this? Please you discuss with me. Otherwise, I have to close this session. It's fine. Is anything else? Okay. Take these notes, and you have to do study in your home. And any doubts arises, please contact me. Thank you all. Now, next, Maths madam is taking the lecture. She is waiting for to conduct. Please, you have to join with the maths lecture at 4 o'clock. Thank you all. Now you can leave.
Okay, sir.
And from tomorrow again one more lecture I have to take extra. So the last unit, nothing but 8th unit I have to start it at tomorrow. Thank you all. And now you can leave the meeting.